4.4 parabolas. It's a very exciting time in math here because parabolas is one of the very first topics that is pretty advanced math. And so it's exciting for me to teach this to you. You will explore parabolas and quadratic equations a lot in the last book, but this is your first, maybe your second introduction to it. So let's start with something that you know. Okay, you know linear equations, right? We learned the families in chapter 2. You learned linear equation, parabolic equation or family, and inverse family or hyperbolic family. We'll do hyperbola and hyperbolic and inverse family. That will be the next video, 4.5. So we're going to reference our linear equation, but we're not really going to work with it very much, okay? So y equals mx plus b, that was basically the whole goal of chapter 2 was learning y equals mx plus b. That's a linear equation. I know it's linear because the variable x, the exponent is invisible here, but the exponent is a 1, and so that's what makes this a linear equation. And a linear equation, I know, will look like this on the graph, a straight line. Okay, so now if we go to the second family is the parabola family. And I'm going to make this a little bit larger. The parabola family is always going to have a 2 as its exponent. Okay, so y equals x squared. The squared is the part that tells us it's part of the parabola family, okay, or parabolic family. It's also a quadratic equation, which you will learn a lot about, as I said in the last book. But we're going to talk about the shape of a quadratic equation when you graph it, and that is what they call a parabola. It's very tempting to say parabola, but it is definitely not a parabola. It is a parabola. And this is the form that you saw it in chapter 2. But the form we're going to be working with in this lesson is this form right here, and this is called vertex form. And I'll break this all apart for you in one of the next slides. I just want to make sure you know all the vocabulary before we move on. So a parabola is a U shape or a gentle curve. It's definitely not a V. Okay, it's very gentle down here. It does have symmetry. If I fold it along this line, it would be exactly the same on both sides. And it can also be facing downward, also having symmetry, and it would never be facing sideways. You would never see it this way or the other way, because if you recall, that would not be a function, and parabolas are functions. Okay, so you will never see it facing this direction. Okay, so 3 words you need to know: vertex, axis of symmetry, which I guess is a phrase, and parabola. Okay, we got parabola, right? That's a gentle curve. It's got symmetry. It's facing up. It's facing down. And it's represented, it's part of the parabolic family, which has an exponent of 2 on our variable x. Okay, see, x, it's a little bit more hidden here, but it's still x minus h is still squared. So we got that one. So axis of symmetry, that's going to be the line in which, if I drew a line, let me get a straight tool here. Let me get a dotted line. Okay. If I had a dotted line going straight down here, that would be my axis of symmetry. And if I did it just perfectly right, which this one looks a little bit off, it would be right along that axis of symmetry, meaning it would be right along the fold. So if I were to fold along this line, you would see that the parabola would be exactly the same on both sides. That's considered the axis of symmetry. Okay, so here it's the same thing. If I were to drop a line down here, that's not perfect again. I can't seem to get it exactly right on this. But if I were to, it too would be the line at which I could draw I could fold, and you would see the same parabola on both sides of that axis of symmetry. Okay. The third and final term you need to know is vertex. And the vertex is the point at which you have a minimum, or in this case, a maximum. And that point's really important. You want to know the coordinates of that point. So here the vertex is 1, negative 2. And here the vertex is 2, positive 1. Okay, so the vertex is a really important part of the parabola as well. Okay, moving on. So we can see parabolas a lot in nature. You can see parabola in a moon, okay, or a part moon or a crescent moon. You see two parabolas. I see one on the top and one on the bottom. And actually, if you were to plot this moon onto a graph, you could actually come up with the equation for that. We'll save that for another day, though, not today. You can see the parabola here on the Golden Gate Bridge. The cables go in a parabola shape with symmetry. Okay, you can see the parabola here. This jump that this motorcyclist is making, or dirt bike racer, goes off the ramp, goes in a parabolic shape, one that's facing downward, and lands over here. A rainbow is also kind of an upside down or a downward facing parabola. This arch from St. Louis, the St. Louis Arch, a parabola, also facing downward. And a valley, and you know I was on a hike once and I remember standing and looking at the most beautiful valley in the Sierra Mountains, and it was a perfect parabola, or it felt perfect to me anyway. This one is not perfect, but you can see it has a parabolic shape, and a lot of valleys do. And that would probably be another science exploration you could do. So going back to our vertex form, here it is, y equals ax minus h squared plus k. All right, well, it looks confusing. Y is always going to be in our equation. X is always going to be in our equation, okay? So those two will not change. But A is going to be a number, H is going to be a number, and K is going to be a number, okay? And I will do examples on the next slide so you'll see an example. But y and x will always be there because you need those in order to graph on an xy graph. So the first clue is you need to see the squared. If you see x in parentheses with something else and it's squared, then that tells you that this is indeed a parabola, or part of the parabolic family, or a quadratic equation, however you want to name it. A is going to have to do with the kind of like the slope, but it's not called slope. It's how wide or how narrow your parabola is. So a wide parabola would be more like this, and a narrow parabola would be more like this. Okay, so we'll get to that in a few minutes, and also you'll do some exploration of that in the lesson. So I kind of want you to figure that out on your own. What kind of number makes it wide? What kind of number makes it narrow? What kind of number makes it upside down? And what kind of number makes it right side up? Okay, H and K. So long as there is a subtraction sign here and an addition sign here, the number where the H position is and the number where the K position form to make the coordinates of the parabola. Oh, sorry, of the vertex of the parabola. Okay, so whatever number is here becomes your x coordinate, and whatever number here becomes your y coordinate, and that will be the vertex of your parabola. Okay, so now let's look at some exact examples. Okay, so I copied that same slide information over here. Remember, HK was our vertex. A was kind of the width of our parabola, and whether it was upward facing or downward facing. That was going to tell us, the squared was telling us that it was indeed a parabola. Okay, and then x and y just have to stay. So you'll see right here, we've got a y and we've got an x, but now we've got numbers everywhere else. So the first thing I notice is that I've got a squared, so I know this shape is not linear, I know it's not a straight line, I know it's a parabola. The 2 tells me that actually it's going to be a narrow parabola and it's facing upward. Okay, I've got a minus in the minus position, I've got a plus in the plus position, so I know that my vertex is going to be at 3, 4. So I find on my graph 1, 2, 3, 1, 2, 3, 4, and I know that's my parabola. I also know it's a little steep, or skinny, I should say, and it's facing upward. So I know it's going to look something like that. And that's not perfect the way I drew it. Now, if I really wanted to be more precise, I could note my vertex. I'm going to erase that. I'm going to note my vertex at 3, 4. And I know along my vertex is going to be a dotted line That's my axis of symmetry, right? So I know that my parabola is going to be symmetrical on both sides. So I can go ahead and I can pick a value on either side of this parabola. How about 1? What if I made x equal to 1? Like a t-chart. And I said, okay, when x is 1, what is y? Well, let's plug it in. 2 times 1 minus 3 is negative 2 squared plus 4. Well, 2 times, that's going to give me 4 plus 4. That's going to give me 8 plus 4, and that's going to give me 12. I think my plus went away. So basically, I have 1 comma 12 is a point on this graph. So let's see if I even have room for that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, well, it's not really there. But that would be roughly where it is. Okay, well, let me do another one. What if I did 1, 2, really close to my line? What if I found out what 2 was? Okay, I'm going to erase this, and we'll do 2, just because I'm running out of room. So now I'm going to say, okay, x is 2. What is y? So I have 2 times, what's 2 minus 3 is negative 1 squared plus 4. Negative 1 squared is 1. 2 times 1 is 2. 2 plus 4 is 6. So 2 comma 6 is going to be a point on my graph. This one will fit. 2, 1, 2, 3, 4, 5, 6. And if it has symmetry, then I know it's one step away from the line of symmetry or axis of symmetry. I know that there's going to be a point right here. I also know that there's going to be a point right here because it has symmetry. So now I've got my vertex and I've got my parabola. And hopefully you can do a better job with your pencil drawn here that is even more precise. Cool, huh? Okay, so now let's go on to my next example. I'm going to go down a little bit. I can still see my vertex form here. I know this is a parabola because of the squared. Okay, I've got an A that is equal to negative 1/3. Well, negative is going to make it turn downward, and 1/3 is going to make it kind of wide. Okay, again, you're going to kind of learn that as you go through the lesson. Also, you'll see that the signs are opposite the signs here. So that's going to make my vertex at negative 2, comma negative 5. It's a little bit tricky. So if I note negative 2, 1, 2, 3, 4, 5, okay, I've got my vertex. Again, I know it's opening down and I know it's a little wider. So I'm just going to drop my line of symmetry. You don't always have to draw a line of symmetry, but I think it's a good idea when you're doing this because it helps you understand where it is. Okay, and now I'm going to find a couple points. So let's do, what if I did negative 1? I'll do it as close as I can because I want it to fit in my graph. So if I put a negative 1 in here, I'd have negative 1/3 times 1 plus 2 is 3 squared minus 5. So I have negative 1/3 times 9 minus 5. Well, negative 1/3 times 9 is going to give me negative 3 minus 5, which will give me negative 8. So I know I have negative 1 comma negative 8. Okay, so that point is right here, which means that over here would be my next point also. Well, this isn't feeling really much wider than the other one, but perhaps if we did more points and had a larger graph, you would see that it actually is a little bit wider. So my goal is to be able to identify that this is a parabola and then be able to sketch a graph with an axis of symmetry, a vertex, and probably 2 other points on a grid. That's your goal of this lesson. Good luck.